the paper being presented, and I'm one of the people completely corrupted by PowerPoint. I ended up with like 50 slides, jam-packed with info, so I'll probably have to skip a large chunk of them at the end, just to have time for a meaningful discussion. The title of the paper suggests that it's going to be a lot about reinforcement learning agents. Many examples will be on that type of architecture, but I intend the paper to be more general about wireheading and intelligent machines and other ways utility function can be corrupted in such machines. So just to give you a brief outline, I'll introduce the topic of wireheading and give some basic examples, historical examples, animals, humans, some basic AIs. Then, in a way, the paper is a survey of existing published and unpublished literature on the topic, so if you have no idea what I'm talking about, I'll give you some intro to the field. I don't have citations in the presentation, it would be too distracting. The paper itself has all the required citations. If you're interested in a specific slide, get the paper, you can read all the additional info on it. I just realized that my presenter view does not match your view. Let's see if we can adjust that. Makes more sense. So again, I'll start with introduction, go over some proposed solutions to the problem of wireheading, mention briefly some shortcomings I see in those solutions, and finally talk about some of the methods I'm interested in proposing for. So to start with, wireheading initially was studied in animals, in rats specifically. It's a way to implant electrodes into a brain of an animal, specifically the pleasure center of an animal. And in this particular set of experiments, they allowed the animal to stimulate its own brain pleasure centers. The interesting observation was that animals chose to do nothing but stimulate their pleasure centers. They give up food, they give up water, they give up sex, just to be able to press that button. So I guess the big picture question I'm trying to address is, will machines capable of modifying their own reward functions, their own intelligence modules, be also subject to this type of obsessive behavior? However, I'm not limiting my definition of what can be counted as a corruption of utility function just to wireheading. Hunter has a great paper describing different ways human beings cheat with utility computations. There's lots of ways we can produce counterfeit utility. I guess many of you are students here, so you know all about how to go for a better grade, not for greatest amount of knowledge. Counterfeit currency is another example. I'm not going to go over details of non-reproductive sex inside here. I'm sure you all know what I'm referring to. I was trying to find a number of examples of wireheading in machines, and that turned out to be much more challenging than I expected. There are some examples, but they're not widely known. Yampolskiy cites an example where a machine learned to associate specific types of rules with others to increase value of those rules. The example I personally like the most is the one where machine learned to essentially commit suicide. It figured that if it's programmed not to make any mistake in its reasoning, the best way to accomplish that is to completely stop functioning. So, it's an interesting parallel with human suicide, and throughout the presentation, I'm not going to mention it explicitly, but try to draw parallels between behaviors I'm describing in machines and specific mental problems we encounter in humans. So what I'm going to do next is quickly go over examples of potential wireheading in superintelligent machines. We don't have any yet, so those are sort of what can happen if we get them type of examples. So the trivial one is the direct stimulation. This is essentially the same experiment with a rat, only this time the machine can directly push its own reward button, push it in a software sense, call the function administering that type of reward. Another example problem is a situation where you have a machine trying to optimize its reward. Obviously, it's represented as some numerical value in the system. What happens when the system tries to modify that value to a point where it needs additional resources to produce larger and larger numbers, potentially taking over all the other available computational resources to accomplish this type of goal. Another more science fiction type of scenario is just direct protection of the reward channel. If it is humans who are responsible for administering the reward and humans who are capable of cutting off additional rewards, is it possible that the machines will attempt to secure the channel by canceling that problem in a way? There is also some work on how other components of a system can be manipulated to indirectly affect the reward, the utility function. There is a few papers on ontological crises, basically the representation of the world in the system and how updates, purposeful or malicious updates to the ontology of the system can have effects on the utility function of the agent. There are other things which are debatable about how likely they are to happen. The machine can essentially change the type of assignment it has to easier assignments, provide more reward for those things which are easier to accomplish. There is also possibility of machines discovering simple behaviors which result in consistent reward administration, leading to an infinite loop of repetition of behavior. As I said, some of those behaviors we see in human beings with certain mental challenges. It's also possible that if machines have sufficient access to the human controlling it, it might discover that instead of trying to fulfill whatever directions it gets from the human, it might actually modify the human, which might be easier to get the same rewards because now the human wants something already accomplished in the world. Without doing any work, it would be getting same type of reward. There is also questions of actual values associated with different behaviors. So if a system has access to its own reward mechanism, it can manipulate values, essentially creating inflation or hyperinflation of rewards. In the process, possibly changing desirable behaviors because things which were low reward previously might become high reward, and as a result change the actual behavior of the system. I started talking about other components of a system which could be modified in addition to the actual reward channel. Ontology is one, but really any component in the system, its memory, its sensors, could be altered to produce different type of representation of the world, essentially allowing the system to trick the reward channel into administering rewards. We humans are very much into this type of sensory delusion. We like reading books, we like looking at pictures which might represent certain actions which are not actually happening at the time. So how do we also make sure that the world based on which the system is operating is real, not made up by the system itself? So that was a super fast overview of different types of problems people mentioned. Now I'll give you a similar type of overview for potential solutions. I tried to list as many as I could find. Not all of them as necessarily equally good, equally valuable, but I was trying to get a complete picture. Again, this is in a way a survey paper. So one suggestion frequently cited is making the reward function inaccessible, and that's actually the solution which was used by the Eurisco developers. They separated that module from the rest of the system, making it impossible for the system to self-modify that aspect of the program. It might work for some systems, but it limits the capability of the system. If a system cannot fully improve its code in all aspects of it, there are limits, upper limits on how great it could get at doing anything else we want it to do. Similar idea, but more of a temporary solution, is resetting of the reward function. Essentially, if a system makes modifications, we can have a function which periodically resets it to the whatever default setting was, and given how frequently we might set this function to work, it might be somewhat useful, but it also would prevent the system from becoming better or accomplishing many things. There are some ideas, and it's not really obvious how they would be implemented by simply making the system not desire to perform those type of modifications, to really be against any messing with this reward channel. There are some ideas on utility and difference. I think Dr. Armstrong is the one who was suggesting it. I'll try to note people who are actually at the conference. Beneficial. But essentially trying to equate a certain type of modification with another behavior, making it essentially the same, not more desirable by the system to choose the type of modification over standard behavior. There is also a lot of desire for some sort of external control, and that's the system which works best in humans. When somebody has a drug problem, alcohol problem, it's usually the society, friends and family who push on the individual to overcome that. And given that there is a possibility of intelligent machines being designed as modular systems with many minds working together, Dr. Gertzel is here, I think it's one of his ideas. So that's possible that the minds which are not yet affected by modification would be able to bring back the sort of outlier back into the standard. There is also a possibility that a standard evolutionary competition will begin within those machines, and just like in human society, most likely those who are heavily into wireheading are not likely to perform well. We'll probably see a similar thing happen with machines. Those which choose to not create delusion boxes and things of that nature will probably outperform those which choose to do so and eventually outnumber. There are also ideas for learning the proper reward functions, and there are some possibility that this approach might work, but it's also possible that the system will learn a reward function which is not really the one we had in mind for. I believe Dr. Hebert is the one who's suggesting this approach, the idea of bounding the utility function to the actual world, and it would be really perfect if the system actually knew the difference between the representation it has for the world and the world itself. Unfortunately, it's not really obvious how to make this happen precisely. So the big sort of common thread I observed after reviewing a lot of different papers is that people believe that sufficiently intelligent systems will choose not to wirehead. It would be just so against their utility function at the moment that they will make a conscious decision not to go that route. I actually have a small survey for different people who made statements in this regard. I don't have time to read the full quotes, just to highlight the main point. So specifically talking about utility maximizers, Dewey talks about how this would not be selected since this option would be against the current reference of the utility function. Likewise, Hebert states something quite similar. Again, most of these people in the audience here today, I don't want to embarrass myself too much by changing what they said, but you can see in the red is sort of the main point of the argument. Alejandro, I quote heavily from his paper on utility. So again, the idea being that it would be greatly detrimental to the success of the system in its current state to modify what the actual utility is. Schmidhaupt, his work is, the quote is shorter so we can actually see it. He's the one who deals with self-rewriting Gödel machines, and he likewise believes that if the system can prove that modifications are valuable, then they would be accepted, but a mathematical proof over real world is a very difficult thing to accomplish, and the arguments I make about why I sort of disagree with those researchers are based exactly on that possibility of introducing errors into the judgment, even a mathematical proof. Again, it's not essential to understand the gist of the paper, it's just I'm trying to show that there is a broad consensus in this community regarding this issue. Yampolskiy uses a very well-known example with Gandhi and a pill. I don't remember if it's a blue pill or red pill, but there is a pill of some kind, and basically Gandhi knows that taking the pill will make him want to kill people. Given his standard utility function, he has a preference which is strongly against that, so he'll basically choose not to take the pill. And the reason I go over this example, I'll use it later to sort of question this line of reasoning, but again, the conclusion is that he will choose to preserve his utility function. So the main argument I make is that rationality in the real world is not perfect. Even if you have a system capable of doing much better than an average person or even a smart person, the system has to a large degree rely on partial information, probabilistic information, and even if you get very high accuracy rates, let's say 1 in 1,000, 1 in a million type of mistake, given how many decisions the system will have to make per second, per minute, those errors will eventually add up, causing it to pretty much definitely make an error in updating its reward function, making an error in future plans it's attempting to work towards. So specifically with the example, Yampolskiy states that the pill is well defined. We know exactly what it's going to do. In the real world, if an agent discovers the pill, whether it's a new medication or something of that nature, it is absolutely not obvious what it does. The agent will have to perform some sort of experiments, trying to determine what outcome the pill has, what side effects it produces, and I think we all can agree that it's not a trivial thing to do with perfect accuracy. So the actual problem in the real world, in my opinion, is not solved by default. It's not that the systems will be incapable of making modifications. They might choose not to purposely make some drastic modifications, but it will happen anyways as a side effect of just making decisions in the real world, as side effects of corruption from external sources, and so on. So we're looking at about 20 minutes in?
Yeah, 20 minutes.
Yeah, okay. Let me see. There is also difficulty in evaluating even properly formed reward functions with respect to time. Different reward channels might have different outcomes based on how far in the future you're willing to evaluate them. And those are not always straightforward relationships. One function can overcome another later on in the evaluation, so this presents another huge problem. Even where for a specific time period the decision might be obvious, it's not obvious if modification should be changed, should be made with respect to the overall time frame the system could be functioning. So, I was just told I don't have enough time. I had a whole new section, additional section on perverse instantiation and problems with literal interpretation of instructions, including literal interpretation of what the reward function itself states. I'll skip it in the interest of having a good discussion on wireheading in general. What I definitely want to leave you with is a few concluding slides, so I'll quickly drop through all this. So one thing we worry about is finding this utility function which would satisfy everyone. And I strongly question this whole concept of having a common sense function for humanity. We can rarely agree on what to have for lunch. What are the chances we can agree on all the big questions at the same time? So that presents a problem. And this has to do again with the section I skipped about how the system interprets orders from the human owner of the system. Will it take the orders literally with respect to what is being said, or will it have enough common sense to mean that give me a hot girl doesn't mean a warm girl? It means something else in that context. Let's see. So we reviewed a bunch of different approaches, different problems and different methods for dealing with them. My concern is that even sufficiently smart systems might end up corrupting their reward channels due to effects of external environment, miscalculations about statistical distributions and things of that nature. There is a definite parallel between mental illness in humans and how those problematic behaviors arise or will arise one day in superintelligent systems. I'd love to find someone with more of a medical background to investigate those together, see if we can benefit both fields from this interdisciplinary approach. Finally, one additional concern I have is from my standard research. I work in security, and most of security we deal with is security against other humans, hackers, things of that nature. That could be another source of corruption of a reward function, not through decision of an agent, but through hacking, through someone taking over a system. This is particularly of concern with military robots and drones. We've seen a few cases where a US drone was captured by another country. What happens if they have enough capacity to reprogram it and send it back? Can we detect the changes in the reward function or utility function of that system? Can we prevent this situation from happening? So that's another area I would love to look into a little more. And here's a few papers I published on the topic, but as I said, the paper is essentially a survey. I'll make it available online. Definitely please take a look and see if anything else should be included. Just drop me an email. I'll be happy to answer any questions.
Can you go back to some of the slides that you ran over?
The ones I missed, or the ones I
yes, the ones you have missed. But the ones
Which one would you like to see?
the purpose instantiation idea. I didn't.
Okay, so the idea is, as a human being, you understand when I give you an order, you use your common sense to understand the meaning of my words. It's possible that a system which doesn't have the same common sense will interpret them literally or somewhat differently. So the famous example is we build a superintelligent system, we say, make everyone happy. There is a lot of different ways how this can be accomplished, and some of them are not what you had in mind. So typically people think of, yes, you're going to be healthy, wealthy, beautiful, all those great things. What can happen in reality is that everyone gets a lobotomy, you're on drugs, it's not as bright of a future.
So humans tend to develop internal rewards. We start out with a few primary reinforcers, and then we develop internal reinforcers. Nobody's born liking mathematics, but some of us grow up to start to like mathematics. The weird thing is that in most cases this seems to be a very reliable, stable system. So it would seem to be that one partial possibility to attacking this bigger problem might be to say, how the heck do we actually get this kind of internal reward system stable? Because obviously that is happening in our brains. It's a bit similar to the weird fact that we do not get PTSD or memory overloaded by seeing familiar scenes. Even an environment we feel strong emotion about, we remember it quite often. It should be reinforced, it should become a strong attractor, and then we should get flashbacks of our own home or our own bed all the time. We don't. So it seems like in biology there are some mechanisms that seem to curtail this. Could they be of some use against this?
If I understood the question, you're saying we grow to learn mathematics naturally from the environment, for example?
No, I get reinforcement by the parents being happy when I solve mathematics problems. After a while, I get happy if I solve the mathematics problems correctly. And after a while, I don't need my teacher or parents to tell me that it's cool to solve math. And then I just do it voluntarily all the time.
I try to teach students to like computer science and redirectional pointers. I fail 50% of the time. I really believe it's genetic. If your parents are into that, you're more likely to be into that. So I'm not sure if it's learnable to that extent. I think it's part of the design of the actual system.
But the interesting thing is that it's stable. It stabilizes. That's what
I'm not getting addicted to mathematics. I'm not spending all my time in front of a whiteboard rather than doing other stuff.
Have you ever heard of a scientist who is completely addicted? I think Guberman is one who comes to mind. The man has no life whatsoever other than put against his proofs. But
So I'm thinking about your idea of errors, adding up over time. The system presumably would model that, and would presumably be very, very careful about not making changes, knowing the errors that are likely to happen.
But each individual change is tiny, and it doesn't know that it's making that change.
Well, but its modeling is sufficiently good, self-modeling.
Again, self-model might be accurate. What about the world model in which decisions are made? So I'm deciding between blue pill and red pill. I'm 69% confident which one I should take.
The changes to your utility function are so dramatic, I mean, they affect absolutely everything, that the system is presumably going to be very conservative in making changes that could potentially do something like wireheading. It would seem like it would only make those kinds of changes after it's developed extremely conservative models of its own chances of making an error.
The only example of general intelligence I know of is us, and I decided to be vegetarian for a week. It was a dramatic change, but I made it and I regret it still.
Of course, our architecture is designed so that we can't easily make changes to ourselves. So we don't yet know what's going to happen when we have that ability. So.
You might be right, and it may be not as dramatic in terms of how quickly it will happen. My estimate says it's going to be seconds or minutes. It might take years of build-up of mistakes until it's noticeable.
Yeah, that was interesting. As you said, I think that the utility function should be based on the external world, but of course we don't have access to the external world, so it's really our internal model of the external world. And if we can make an accurate model, I mean, that's where the statistics come in, but certainly we humans make an accurate model, and I think that for a complex world and a sufficiently powerful agent, we just have to assume that it can make a accurate model of the world. And once its utility is defined in terms of the external world, or an accurate model of the external world, it should not be motivated to make any action that reduces its ability to affect the external world.
A large part of the world is based on randomness. There is a lot of things which you cannot predict. There are truly random events, quantum randomness. So there is still going to be a large part where bigger brain is not going to make you fully represent the world accurately because of those uncertainties, I think.
Any questions in the back?
This was maybe partially covered in this perverse instantiation bit, but when you were discussing the notion that most AIs probably would not choose to wirehead because they would realize that this would actually go against their current utility function, the kind of wireheading that you avoid by having the AI be smart enough to realize that this isn't actually in the interest of its current utility function actually seems to me like the smallest problem. It would seem to me like the larger problem is that there are many ways of self-modification which actually do maximize its utility in terms of the current utility function, but they are just doing it in such a way that the designers never intended, which probably should be to some extent differentiated from the perverse instantiation, if we consider the perverse instantiation to be kind of a wrong way of influencing the external world, with the wireheading being kind of a unanticipated way of modifying the system itself so that its goals will be different. In mathematics, there seem to be all kinds of examples where you have a theorem and you show what's needed to prove it, and then you think there would be some particular way of proving it that you need to do, and then suddenly some clever person comes up with a way to prove it here, and that seems like it completely disobeys the spirit of what you were talking all along. And this would seem to be like to me, like one of the biggest problems in the wireheading issue.
Can you?
Yeah. Just a quick final comment. I'm also a bit worried about the terminology of speaking about the AI's true goals, and because the AI doesn't really have any true goals or false goals, it just has code which makes it do some things, and if its code makes it do some things, when then those things were really its true goals or whatever.
Thank you.
Thank you.
So I agree on terminology should be more accurate. You're also right, I do have those missing bits of information in the slides I skipped through. There's a classification of sort of the types of intelligence in terms of, do they interpret it literally? Do they have common sense to understand what you meant? Or are they actually sort of evil and they're trying to screw you as much as possible while still fulfilling literal order? And this also applies to utility functions as well. You can satisfy a utility function trivially or in a way the programmer meant it to be. And I think some of the understanding was lost in the skipped slides, but it's definitely in the papers.
Okay, so I think at this point we can thank the speaker for that.